Okay, let's go ahead and take a look at discussion 7 here. Wanted to provide a little bit more insight to the problem. A couple things. First of which, how to do the search for the seating capacity of your event center, as well as what's listed in section 11.5 inside your textbook. The rules of Powerball have actually changed. So I want to show you via Microsoft Excel how you can get to what it's asking inside the second part of the problem. And then I'll leave the last question, how does this change your view of lotteries, after we go through the mathematics that's involved. Keep in mind in the initial post, you do need to ensure you show all of the mathematics that's involved inside of the initial posting. You just can't state the answers. I want to see the underlying process when you do that. So question is, if you were to pick a center, I picked Arrowhead. You can pick any event center where you would go see a concert or a musical event, etc. But I'll show you how I got to the 76,416. So I'm going to open up Google here. And once I open up Google, I'm going to type Arrowhead Center seating capacity, do a Google search on it, and you'll notice up here, that is where I'm pulling the 76,416 from. So doing a simple Google search will allow you to come up with whatever that seating capacity is. Now, if I come back to this first part of the problem here, it's asking, imagine an event center, if they draw your seat number and you win $1,000, what's the probability you'll win? The $1,000 has nothing to do relative to determining the respective probability, because each seat that is inside of Arrowhead has an equal chance of winning. So it doesn't mean if you're in the lower terrace versus the nosebleeds up in the upper deck, everybody out of the 76,416 has an equal chance of winning. So the probability is going to be identified first by establishing a ratio between these two respective values. So the denominator is going to be out of whatever value you end up choosing. So the 76,416, there's only one winner that matches the criteria. So 1 out of 76,416 would be the probability that you would win that respective $1,000. Again, the $1,000 has nothing to do with the chance of winning. That is the outcome of if you win or not. 76,415 people aren't going to win. Only one will win out of the 76,416. So that's going to get you your probability. Your denominator has to be different than what's listed here. That's why I listed in bold. You cannot use Arrowhead as your example. You need to use your own respective value. Now, let's talk about the second part of this, the Powerball rules. And as I made mention earlier, what's listed in section 11.5 inside the textbook, the rules have changed relative to utilizing Powerball. So I'm going to go ahead and start a new screen here so we can see what's going on. So I'm going to do a new document. Okay, so let me clear out that. All right, so Powerball as of today has two respective urns. You have your white balls and you have your red balls. The white balls, instead of 59, now has 69 individual white balls that are in there. To win the Powerball, you choose 5 of the 69 there. Red balls have now decreased to 26. You choose 1 out of the 26. Since you are choosing out of these, both of these are going to be representative of a combination. So the way that this is calculated is a combination of 69 choose 5, and for the red, you're going to choose 1 out of the 26, and take the multiplication of those two values. There's an easy way to come up with this respective value inside of Microsoft Excel, and I'll show you how to do that here shortly. So let me open up Microsoft Excel, and I'm just simply open up a blank workbook. Let me make the print here a little bit bigger so you can see what's going on. And what you need to type inside of the cell, there is an intrinsic or built-in formula, and I talk a lot about this inside of LP7's homework, is what's called combin, C-O-M-B-I-N. The first component is 69, choose 5. The sample size of 69 and how many we're choosing out of that group, which is 5. So if I do 69, choose 5 times, and I need to do the same thing for the red ball, the 26, choose 1. So I'm going to do a combin 26 times 1. If you do that, and let me put some commas on it so we can see this a little bit clearly, and get rid of the decimal places, there are 292,201,338 options in terms of the total amount of outcomes that are in Powerball. It has substantially increased since the publication of your textbook. This used to be 59 over here and 30 some odd over here. So the number you want to use as to answer the second part of the question is going to be out of this 292,201,338. So again, if you look up here at the top, that is what needs to be typed into the cell to get to, clear that out, the 292,201,338 as the total amount of outcomes that are associated with Powerball. Okay, so let me clear out my markings and let's go back to the second part of this question. So the remaining part of this asks for, let me minimize that, 76,416. It says, how many event centers would it take possible to get a respective seat? To get that second part of your respective response, what you're going to need to do is start out with, again, let me bring this back over. This 292,201,338. So let me make sure one more time here. 292,201,338. 292,201,338. And divide by whatever you end up using, the 76,416, as the result. So I could actually go back into Excel and do that respective calculation if I wanted to. If I went in and utilized that value and divided by the 76,416, you'll notice that it would take 3,824, because you'd have to actually round up. There would be a total of 3,824 stadiums that would be required to fill up to actually encompass all 292 plus million different options. So that's how the calculation's done. Look forward to your posting. Again, you cannot use Arrowhead Stadium as part of your initial post. Thanks.